So in today's class, I have no plan to teach you guys. I have no plan to teach you guys. Everybody settle down. This is what you all did in the test. And as you all know, I never believed in giving score to anybody. So you will not get your score, say, okay, I got 80%, 90%, 60%, 20%, 99%. No. I don't believe in giving that result. What I believe in by the test is to get into the insight of what you guys know, where you are struggling, what you need to learn better, where I can put more energy and focus to make you guys more comfortable with the concepts. So before I share my findings without calling out names, I'm not going to share anybody's name, okay? Say, okay, you did this much. No, not that way. My observation will be more specific to the class. Hello, Sohina. So my feedback will be more specific to the overall group rather than any individual. Okay? So now tell me, honestly, who nailed it? If anybody thinks that you nailed it, no? So many crying faces are up, that doesn't help. It's okay. Don't have to cry for the test. Arihan, what do you think? You nailed it? No? No. Okay. And that was such a honest feedback from some of you. And it's okay. We are not here to get 100%. It's not about 100%. It's about the focus on learning new things. So let me hear from. Okay, you did level 1 because you're fresh into level 2. It was too early for you. Myra, what do you think you did in the test and where you had an opportunity for doing better?
I think in the test I was more focused on position. And I think I could have done better on exponents.
Okay, exponents. That is where Myra feels that she can do better in exponents. And again, trust me, you all have to be as honest and transparent about your own assessment. So, Dikshita, what do you think, beta?
I think I did part of it, but not that.
One more time.
I think I did good, but not very good.
What does it mean? Tell me some more insight. Which topic you think you could have done better?
I don't remember, but there's this one question, like in something like in this one or something.
Okay.
Like it says like if it's fractions. Yeah, that's the one I used to.
Exponents. Okay. Adya, tell me, beta, what's your reading? And it's honest, beta. It's perfectly fine. I'm like a doctor, okay? To whom you are coming. I'm not a doctor by profession, but it's like a maths doctor. You'll say, okay, doctor, these two math is giving me a problem. Do you have a fix for it? I'll find a fix, try to make it easy for you, and then that becomes your strength. So that's how you guys have to treat it. Okay? So what is your reading? Again, I know you have done only a few classes, not many classes. So obviously there'll be a lot of things that is new to you, right?
I think I can do better on finding values, x and y.
Okay. So basically algebra. That's what you're saying. Okay. How about you, Sanvi?
Angles.
Angles. Okay. Abhirav, how did the test go and where you think you can do better?
I don't know. I never saw my test.
No, you did not see your test, but just by looking at the question, you would have seen, okay, these are the areas where, no, it was not fun.
Fraction multiplication.
Fraction multiplication, okay. Urvi, you're reading better. And be honest, it's okay. I mean, nobody cares. It's fine. We are just here to find out what we can do better. That's it.
I think I could have improved on all of them.
Okay. And again, for Urvi also, she is also very new to the class, so not a lot of things that we have covered. They've been part of it. How about you, Saina? Not putting you on the spot. I'm sorry, beta?
The whole paper.
Whole paper. So the kids who came fresh from level 1 to level 2 or some other kids who joined recently, obviously they haven't got chance to go through a lot of concepts. So that is where we had opportunity for doing better. I'm not going to give this paper or marks to anybody saying, okay, this child got this much, this child got this much. I'm going to trash it now. All the information that I have to extract from this, I have extracted, okay. So this is not going to be of any use for me.
We can have seen.
No. That's not. Okay, let's move on. So my reading is this. I gave a feedback also. I saw that the geometry concepts where we are applying the understanding, the properties and to derive some values, that was one area. I saw everybody struggling with components or not components, exponents. Wondering what is component here. Yes, Arav.
Oh, what if I said geometry questions are too small to read?
So again, there is no point defending it. I'm not saying it's Arav or it's Myra. I'm saying for me, everybody as a group. Majority of the concepts I'm talking about, okay? I'm not pinpointing anybody. I'm just saying that exponents we struggled, geometry we struggled, word problems we struggled. Did we struggle with everything? No. Not that way. Many of you did good also. But I'm not calling out name or to differentiate among you all. But I saw there were opportunities. So what it means is, hereafter whatever we will learn, we'll have to make sure that you guys are practicing those. So when I give assignment, I have called out very clearly that when I give assignment to you guys, make sure that you do the assignment step by step. Even in the exam, 90% of you have not shown the steps. So I would, not 90%, probably 80%, have not put the steps. I would not know where you are going wrong. Seeing the question and seeing the answer doesn't give me any clue. You guys know my limitation. I'm not that intelligent by just looking at the answer. I'm not ChatGPT. I'm not normal human being. Put in any role. That's it. So you have to do the steps. That's a clear message. Okay? And when I give the assignment, again, assignments also, every problem you have to do step by step. Show it to your parents. Explain them. Say, okay, this was the assignment. This was the question. This is how I've done it. This is my answer. Before the assignment comes back to me. And those are not to scare you. That is just to enforce that practice on a day-to-day basis for solving problems. Okay? Because math is not something that will come in one day. It is not like lightning that it will strike you one day and you will become a champion. We had a lot of lightning in the morning. That's why I found that relevant. But math is like practice. Okay, it's an everyday routine that will make you more comfortable. So we'll start with exponents. I want to see where and what are the concepts of exponents that is haunting my kids. Okay. So let's start with exponents. We'll learn exponents today. We'll talk about basic exponents. Then we'll talk about rational exponents tomorrow. And encourage everybody to participate in the class, because if you don't participate, I would not know if I am able to make sense to everybody or not. Okay? So let's start. Exponents. Anybody in the class who is not aware of what is exponent? Just exponent has a definition. Like if somebody says, who is your math teacher, you'll say Virendra Kumar. So likewise, what is exponent? Anybody?
It's just number multiplied by itself.
A number multiplied by itself. That's one definition given. Yes, Sami.
An exponent is like, for example, like 2 cubed, you have to multiply the number by itself as many times as the exponent on the top.
Other power. Okay. Yes, Anvita.
Yeah, I was going to say that an exponent is the number of times you multiply the number by itself.
Okay. Yeah. So now the thing is, first thing before we try learning the concepts or revising what we already know, why do we need exponent? I have 2 into 2 into 2 equals 8. No big deal. I know it. Somebody says 2 into 2 is equal to 4. Everybody knows it. The problem starts when somebody says 2 into 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 2. See how jobless I am right now. If you have to write something like this, so much of ink is getting wasted. And ink, do they come from trees? No. You're not cutting tree for writing, right? Okay, that's good. Okay. Now coming back to a serious discussion. I have how many tools? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. I can write this as 2 to the power 13. See how easy and neat and clean it is. If you write like this, you can also say this as 2 to the power 3. You can say this as 2 to the power 2. How clean it is. Imagine you're dealing with 2000 2's at the same time. They're getting multiplied by itself one after another. If I have to write 2000 times 2 into 2 into 2 into 2, I need to take 2 days off from my work. Yep. I can write that in 5 seconds. So this is a new method of representing numbers when it is getting multiplied by itself. That is what Sami and Sarvita also said, or Myra here. That exponents are a way to express numbers, a bigger number, in an easier way in this form. What is this called? This is called the base, and this is called the power. And this is the exponent form of representing a number. No questions so far? No questions so far? Adya, Urvi, sorry, everybody clear? Now, Advik and Arab, you guys might think that this old man has taught this 5 times or 6 times already. Don't worry about it. I will find out some element of excitement in what we do. So, tomorrow if somebody says 2 to the power 3, then you'll say, okay, fine, that is nothing but 2 into 2 into 2, 3 times. That's it. Sandy, Adya, does it make sense enough? Yep. If I say 2 to the power 4, that is nothing but 2 into 2 into 2 into 2. If I say 7 to the power 3, that is nothing but 7 into 7 into 7. Yeah? Everybody with me so far? All looking like very lame, easy concepts. And they are easy. I would not say lame, but they are easy concepts for sure. Now, if I add more spice to it and say, why 2 today? Today is not the 2nd day of the week. Today is the 6th day of the week. So let's put 6. 6 to the power 3 into 6 to the power 4. How much is that?
6 into 6 into 6 into 6 into 6.
Now you tell me that many times 6. Yeah. $10,000. Yep. Everybody who disappeared from the screen, please keep your videos on. And this is what I was trying to learn. That if I have one exponent, I know what is the meaning of it. When I multiply one exponent with another exponent, this is what happens. Like what Myra said is, here if it is 6 power 3 and multiply by 6 power 4, it becomes 6 power 7. Meaning these 2 powers get added. I don't believe in that. I would want to see it myself. So 6 to the power 4 into 6 to the power 7. 4 into 6 power 3. So 6 power 3 is nothing but 6 into 6 into 6, 3 times. multiplied by 6 to the power 4. 6 into 6 into 6 into 6, 4 times. So this is this and this is this. Oh, what do I have? 1, 2, 3, 4, 5, 6, 7. Oh, that is 6 to the power 7. Oh, so what Myra was saying was actually correct. So this becomes a new rule of exponent where you say if you have any number x, I'm calling it x, x could be 200, x could be 1.5, x could be 900, x could be 5 million, or x could be 20 trillion also, to the power a, and you are multiplying that with other number, same base, to the power b, it will become x to the power a plus b. See, this is your x, x to the power a 3, x to the power b 4. Here is your x 6 and b is your 4. What happened? It became x to the power a plus b. A plus b, 3 plus 4, 7. So this is your first rule of exponent. Does it make sense? If I say 3 to the power 2 into 3 to the power 1, you will say, okay, x, this is my x. X to the power a, x to the power b. It becomes x to the power a plus b, 2 plus 1. And this is not x, this is 3 here. So 3 to the power 3. Yeah? Does it make sense to everybody? No? No, it's okay, I can go to...
Isn't 3 over 1 3? Is it, or is it 3 over 1?
3 over 1 is 3 only. But if you write 3 or you write 3 over 1, it's the same. 5 or 5 over 1 is same.
Yeah. Why is it 2 plus 3 to the power 3? Oh, that is 2.
Yeah. This 2 and this 1. Is everybody clear?
So it's just 2 technically, because that equals 3.
Yeah.
So what's the point of adding 1?
I'm adding 1 because when, see, I'm multiplying two numbers which is with the same base. Here you have power, here you don't have power. If you don't consider this as 1, you'll say, okay, 2 plus 0. This becomes 3 power 2, but that is not the case. Yeah.
Sorry to interrupt, but if you're multiplying 3 to the power of 2 times 3 to the power of 1, wouldn't you get 9 2 times?
No.
9 2 plus 1?
No. Let's see. Again, think of it in the simplest form, okay? Don't actually over-calculate. Always make sure that your hands get as dirty as mine. Meaning, let's say 3 to the power 2 into 3. Yeah? If I have no power, that is 1 power. 2 or 2 to the power 1 is same. Okay? So if I have no power, if I am multiplying this and this is one exponent, this doesn't look like exponent. I have to convert or make it look like an exponent. Yeah? I will make it look like an exponent. Now, this into this becomes this to the power this plus this. Or even if you don't worry about this, what you will see here is, okay, you have 3 to the power 2, that is 3 into 3. And then multiply that with a 3. So this is this part, this is this part. Yeah? Now how many 3's you have?
3.
3 3's. So that is 3 to the power 3.
Oh.
Making sense? Everybody? Sammy? So again, 3 power 2 is 9. So 9 into 3, 27. That is how you look at it. But right now we are thinking in exponent terms. I have one exponent. Make this also look like exponent. Like you guys would remember, right? Whenever we are trying to add fractions, let's say 5 over 3 plus 2. Oh, I have told you guys so many times, fractions are my best friend. If I have a fraction, I'll convert everything to a fraction. This guy doesn't look like a fraction. So, see, now I made it look like a fraction. Yeah? It's the same number, just looking like a fraction. And then you'll do your fraction calculation. Same way here, this is your exponent and this is just a natural number. You have to make it look like an exponent. How will you do it? 3 is nothing but 3 power 1. Yeah? Is that okay, everybody? Urvi, Sanvita, Suhina, everybody? Arihan, Sammy? Okay. I know sometimes I might get very boring with math concepts and I make you guys fall asleep. That is when I get compelled to crack dad jokes to wake you guys up. Okay? Alright. Now, you saw this thing. So, only takeaway from this is that when you are multiplying exponents, this is your new formula. X to the power A multiplied by x to the power B equals x to the power A plus B. Where x could be any number that you can think of. Yeah? Now, okay, I'm just checking if there is somebody who joined in between. No. Okay. Aradhya, are you clear, beta? Or I'm going V2 first?
I'm clear, sir.
Okay. Alright. Yeah.
Wait, what if the x, like what if x a is like 3 and then x b is 4?
So this x is 3 to the power what? Let's say 2.
Okay.
And then this x is what?
4.
It cannot be, right? Both are x. It has to be the same.
Then what happens?
Then it's a different number. Let's say, then it's a different number. Let's say 3 to the power 2, or let's say 4 to the power 3. Okay? See, we have the most basic ancient method of doing our math. Nobody can take it away from us. So this is, my base are different.
Yeah.
Exponent rule doesn't apply. This becomes 3 square, that is 3 into 3, 9. And this is 4 cube, that is 4 into 4 into 4. That is 4 4 is 16, 4 is 64. Is anybody stopping us from multiplying these two? No. We can multiply it that way. Just that the freedom, the luxury, the advantage that we have with this rule, that will not exist because your base is different. Yeah? Does it make sense, everybody?
Yeah.
Okay. Even if that doesn't make sense, believe it. I'm just kidding. Never believe what doesn't make sense to you. Okay? So this is one rule. So when you are multiplying exponents with the same base, in the resulting exponent, the power gets added. Adya, do you believe that? Yeah? Okay. Now, what will happen if I say a to the power 5 divided by a to the power 3? I'm dividing right now. Tell me. Think about it. Argue with me without being disrespectful. Yeah.
You just like solve a to the power 5 and divide.
Okay. Now that's the most orthodox method. No denying that. But we'll derive a formula out of it. Like we saw this formula, right? That when you're multiplying two exponents, the power gets added. We'll see what happens here. Yes, somebody had raised hand. Who's going to tell me the story? Yep, Sammy.
So if you multiply and your exponents get added, if you divide, will your exponents get subtracted?
That was a very intelligent answer. Or intelligent guess, I would say, without solving it. And you will see it happening. Because I don't believe in anything that I don't see myself. A to the power 5, what does it mean? 8 into 8 into 8 into 8 into 8. 5 times 8. Then 8 to the power 3, what does it mean? 8 into 8 into 8. Then time to play. 1 8, 1 8 gone. 1 8, 1 8 gone. 1 8, 1 8 gone. What I'm left with? 8 into 8, that is 8 square. This is exactly what Sami was saying. That if you have something here, the numerator, same base, some other power in the denominator, you subtract the power from numerator to denominator. So this becomes a to the power 5 minus 3. If you see what happened here, whatever you had here, that many 8s got removed from what you had in the top. That's why this rule. Make sense?
Yeah.
What is going on there
No.
between two friends? That drawing, that skill is great, better than mine, but not in the math class. Okay? So what it became was a to the power 5 minus 3, that is 2. And if you can look at this carefully, as many 8s you had in the denominator, that many 8s got truncated here or striped off. So you are left with only the difference between this power and this power. So this is your second rule of thumb, or the rule of exponent, which says x to the power a divided by x to the power b equals x to the power a minus b. If you want to be careful, you put it in a bracket. That is what we were seeing here. And mind it, this x represents the same number, meaning you're talking about two exponents with the same base and different powers. Everybody clear?
Yeah.
Urvi, Sanvita, Arav, Aradhya, Suhina. Suhina is probably tired of me asking the same question. She has kept her thumbs right in front of her face so that as soon as I see her, I'll see a thumbs up. But yeah, jokes apart, I'm just trying to. Oh, Dikshita is saying 2 thumbs up? Okay. No, only 1. Okay. So, jokes apart, what I'm saying is, it's not about you guys showing me the thumbs up. It's about you guys giving me the confidence that whatever I'm teaching is actually reaching. Alright? So let's put the second rule. And this rule is only for us to have a guided learning. Okay? So here, what second rule says, if you are dividing one exponent by another exponent, meaning you have two exponents with the same base, it becomes, and to be on the safer side, put it inside a bracket so that you don't get confused. Yep? Because writing things clearly has a lot of importance. Okay? If I write x to the power a minus b like this versus x to the power a minus b, it's a totally different number. That's why you always barricade what you are writing so that no trespassers can get you confused. Yep? Alright? Make sense? Yeah. Arihan. Okay. Urvi, Dikshita, everybody? Nihan?
Yes, sir.
Nihan has not been talking today. All okay? Now I will pick up one problem. No, I will not.
Okay.
Before I pick up, there is one more concept that I have to teach you guys. So these two rules that you guys learned. There are 2 more rules that we want to learn. Maybe we'll look at these problems where you guys struggle a little bit in the test. We'll come to that in the class tomorrow maybe if we don't get enough time. We still have 30 minutes. That's okay. Now the third rule is, let's say I said 3 to the power 5, whole thing to the power 2. How much is that? Can you tell me as an exponent? All the artists, come back to math. Myra, you also. Yes, Suhina.
5 and 2.
Say that again, Myra.
I think we should add 5 and 2, and we should get 3 by 3
To the power 7. Okay,
Yeah.
that's one opinion. Let's see what Dikshita says.
We have to multiply 5 times 2.
Sanvita, what is your point of view, beta?
I think we would do 3 to the power 5 times 3 to the power 5, and then we would just add both the 5s.
I think we should first solve 3 to the power of 5 And whatever that answer is, we should do 3 to the power of 2.
Okay. Arihan, tell me, what is your point of view?
Like 3 to the power of 5, and then that times, like to the power of 2.
Okay.
I just solve for 3 to the power of 5 and multiply by itself.
Yeah, so some of you said that add these two, some of you are saying multiply these two. I'll do none of them. Such a stubborn teacher. Yes, Arya, saying something.
I was just saying that the previous.
Sorry, beta?
I was saying that I would do the same thing.
Which one? Multiply or add?
Multiply by.
Okay. Yeah, Dikshita.
First, we do 3 times, like 3 5 times, and then we add 2 to the 3 times 3 times 3 times 3.
Arav, what is your point of view?
1 times it's the power of 2 by 3 to the power of 5. So I would do 3 to the power of 5 plus 3 to the power of 5. I mean, 3 to the power of 5 plus 3 to the power of 5.
I think your voice was a little muffled. Let's hear Sami, and then I will do whatever I can do with my limited knowledge. Yes, Sami.
So my view is that you would multiply 3 to the power of 5 and by 3 to the power of 5 because it's 3 to the power of 5 squared.
3 to the 5 squared. Okay.
I solved it.
You solve it. Now, same thing. Let me solve it. Like Maya said, she has solved it. There's nothing great about it. Let's see again. As I always keep saying that always look for opportunity to make it simple. Adya, Myra, Tasvik. I mean here. Okay. So here. Now I have something in the bracket, it's square. If somebody says x in the bracket and square, does anything change for me? Whatever I have in the bracket, that into that thing, correct? That's all it is. So here also when I have 3 to the power 5 square, what it means is 3 to the power 5 into 3 to the power 5. Just that it is kept inside the bracket. It's like now a cow with a dress. If you don't write it here, it's a cow without the dress. Yeah. In winter, sometimes you'll see that they put the some covering for the cows also, right? So this is the dress to cover in the winter. Just to make it look separate. That's all. So whatever I have here, I'm doing a square of that, meaning this thing multiplied by this thing. Go back to this theory. X to the power a into x to the power b. This is my x, same base. This is my a and this is my b. A and b are same, doesn't matter. It's okay, it's the same. So this became x to the power a plus b. A is 5 and b is also 5. Unfortunately, doesn't matter. This became 3 to the power 10. So the rule that you have to follow is multiply these two powers. That's it. So look at this. Why it is multiplying? If I had 3 to the power 5 cube, that means it would have been 3 to the power 5 into 3 to the power 5 into 3 to the power 5. 5 plus 5 plus 5, 15. 5 times 3, 15. So the third rule of exponents that we are learning is, somebody raised hand. Yes, Gayatri.
So I can't really see the other side of the board completely.
You can't see the other side of the board?
Yeah, not the other. Those cut off.
Are you able to see my hand?
Not really.
Are you able to see my hand?
Yeah.
Are you able to see my hand?
Yes.
Okay. How about now? Are you able to see my hand?
Yeah.
Okay. You could have told me in the beginning itself. You guys, that's why I keep telling you guys that I make sure not to scare anybody in the class. That means at least you guys, if you are facing any problem, let me know.
Can I go to the bathroom?
Yes, please. Alright. So here, so these are the two rules that you've learned. X to the power A into x to the power B becomes x to the power A plus B. X to the power A divided by x to the power B becomes x to the power A minus B. And the third rule is something that we saw just now. That becomes x to the power A times B. If your exponent is inside a bracket and then you have another exponent outside the bracket, you end up multiplying them. That's the third rule of exponent we learned just now. Now, that is not enough. Unless I get you guys scared, my class is not done. So all this is fine. These three rules are fine. Anybody trying to take notes, don't worry about it because you'll any which way have the video of the class that you can refer to revise. I'm just rubbing it off so that we can go to the haunted part of this topic. So far life was going okay. What is it? 5 to the power minus 1 minus half minus 2.
Negative 25.
Negative 25.
Oh, wait. No.
She's thinking about it. Yep.
Times
I'm sorry. Vita?
negative 5 times negative 5.
No, then I would have written it like this.
Yeah.
But I have written it like 5 to the power minus 2. See, 5 to the power 1 is 5. 5 to the power 2 is 5 into 5. 5 to the power 3 is 5 into 5 into 5. 5 to the power 4 is 5 into 5 into 5 into 5. Now, 5 to the power minus 2. 5 divided by 5? That will be how much?
1.
Tic tac toe. Any thought, Arav? Tell me, your surprised face will not be enough. Tell me, what is going on in your mind? Now think about it. See, math is about exploring things conceptually.
I thought it was going to be negative 25 because normally if you have 5 to the power of 2, it would be 25. And then you added a negative to the 2, so it would be negative 25, right? 5 times negative 5.
Yeah, Arav.
Wait, so the answer is positive 25 because if there's two negatives in like a number set, you can just cross them out.
Advik has been very quiet. Any point of view, Advik?
Oh, sir.
No? Tell me, what is 5 to the power minus 2? What does it mean practically? Now I have a question for you, straight from the bathroom. What does it mean? 5 to the power 2, you all learn. 5 into 5, that is 5 power 2.
Probably covered that bottom part.
Okay, now let me decode this. I have already bothered you guys enough.
Really?
Before we go to this, there's one more concept that I want you guys to learn. Okay, I'll pause this question for now, okay? Now tell me what is 5 to the power 0?
5. 0.
Hmm?
0.
5 power 0 is 0. Okay, Arav? Which one?
What?
It's 1. Any number to the power 0. Any number to the power 0. If I say I'll give you guys 1 billion to the power $0, I'm promising you only $1. Any number to the power 0 is nothing but 1. Except 0. If I say 0 to the power 1, 0 to the power 0, that is nothing but a 0. Except for the number 0, any number to the power 0 is 1. But why?
Because 0, like, they're doing like if it's 0, you would divide like the number by itself, right?
Think about it.
Sir,
Yep.
if you multiply like one to the power of 0, you get 1 because you don't multiply the number with anything, right?
That is correct. What? No, I'm not multiplying. I'm saying any number to the power 0 is 1. But why? Myra, stop drawing. Tell me, think about it and tell me the answer. Arihan is also thinking. Lot of flying, confused, surprised faces. Now, let's look at what did we saw just now. 3 rules of exponents that we saw. X to the power a into x to the power b equals x to the power a plus b. X to the power a divided by x to the power b equals x to the power a minus b. X to the power a to the power b equals x to the power a times b. These are the 3 rules that we learned. Correct? Bhuvi, Urvi, are you with me, beta?
Yeah.
Yeah, okay. Now, these are 3 rules that we learned. Right now, the question that we are all grappling with is, any number to the power 0 is equal to 1. It was going fine as long as I said, yeah, you all are right. I'm not stopping there, I'm asking you why. Can you prove it? And here's the proof. Now look at these concepts that we have learned. If I have 5 to the power 0, okay? 5 to the power 0, can I write this as 1 minus 1? That will be a 0?
Yeah.
Yeah? Yes, Rahina? Tell me, beta.
I see the mistake.
Okay. So 5 to the power 0, I can write this as 5 to the power 1 minus 1. That will be 0 only? Yeah, Rav.
I found out why.
No, right now you have to hold it because I'm in the middle of explaining this to all the kids. So you have to hold it till I complete, then I'll come back to you. Okay? Now,
Stop.
now making sound. Here, pay attention here. I'm your superstar for another 15 minutes. I applied a lot of cream to look beautiful. Watch me right now. Okay, here. So, this is x to the power, 5 to the power 1 minus 1 gives me a 5 to the power 0. Now look at this. Something to the power a minus b, that means a above, b below. So I can write this as 5 to the power 1 divided by 5 to the power 1. A and b. See, look at reverse of this. X to the power a divided by x to the power b equals x to the power a minus b. I'm just putting reverse of it. If this is equal to this is equal to this. That's what I'm saying. I'm converting this a minus b as x to the power a divided by x to the power b. So 5 to the power 0 is 5 to the power 1 minus 1 or 2 minus 2 or 3 minus 3, whatever you call it. And that will become 5 to the power 1 divided by 5 to the power 1. A reverse of this rule that we learned. Yeah? Is it relatable or I'm just blabbering? See this rule, x to the power a divided by x to the power b equals to x to the power a minus b. Or I can also write this as x to the power a minus b equal to x to the power a divided by x to the power b. Correct? That's what I'm doing. I had x to the power a minus b. I'm writing this as x to the power a divided by x to the power b. Yeah? Relatable?
Yeah.
Adya? Sami? Arav? Saurya? Everybody can relate it? Sanvita? So, now you have a situation where 5 to the power 0 became 5 to the power 1 minus 1 or 2 minus 2 or 3 minus 3, and then applying the reverse of the exponent rule, you converted this into this by this. Now look at this. This by this is nothing but 1. Same number in the numerator, same number in the denominator. You don't have to use 1 minus 1. You can as well say 7 minus 7. Doesn't matter. That is how you get a 0 here. 7 minus 7 will get you a 0. 20 minus 20 will get you a 0. And then that is the reverse of this exponent rule that you will apply and find this. Make sense? So far, I was also knowing that any number to the power 0 is 1, except the number 0 itself. But then I had never bothered to think about how is that possible, how I can prove that, how do I mentally align to that understanding. Yeah.
What's the matter?
Yep. But one day I think it was Arav whom I was talking about this one, asking this question, and Arav said, but why? And that was such a point blank question for me. Okay, I had never thought about this till the age of 48. In my 49th year, I learned this. I related this, okay? I was doing some puja at home. I was wondering, how do I answer Arav? How do I prove this concept? Then this clicked that, okay, I can relate that with this theory and then I can see this. So, what I'm trying to say is, this is what makes you believe that any number to the power 0 is 1. Is that convincing enough for everybody? Arihan, Sami, Sanvita, Gayatri, everybody? Suhina will not give me a chance anyway. Okay, everybody convinced? Let's move on. Now, this was not the question. I got you guys distracted. Not because I didn't know what the meaning is. I wanted you guys to be prepared with this thing. Yes, Arihan?
Sir, I have to go.
I'm sorry, Vita?
I have to go. Can I watch the video later?
Sure, just give me $200 and you can leave. I'm just kidding. Have fun. Okay? Alright. So, now we are talking about what is the value of 5 to the power minus 2. Simple. 5 to the minus 2. Can I write this as 0 minus 2? Is this okay?
Yeah.
Yeah? Not kind of. Minus 2, can I say 0 minus 2? Minus 3, can I not say 0 minus 3? Minus 8, can I not say 0 minus 8? Because it's the same thing, right? You're doing minus from a 0. So the value doesn't change. Yeah? Everybody okay? Now, go back to this theorem again. That means something to the power a minus b equals something to the power a divided by something to the power b. Yeah?
That's 1.
1 over 5 to the power 2. What happened? 5 to the power minus 2 became 1 over 5 to the power 2. Meaning, if you have any number with a negative power, you can very well, if somebody says 8 to the power minus 8, you will say 1 over 8 to the power 8. This minus sign becomes a positive sign when you go from numerator to denominator or vice versa. Dikshita, does that make sense, beta?
Yes, sir.
Okay. Suhina, Sami, is this making sense? Urvi,
Yes, sir.
Sanvita, Sanvi, okay. Tasvik, make sure that you keep your notebook and pen ready. Whatever I say, don't have to note down my speech, but something that you find interesting. Okay? Because writing improves your ability to remember things. Okay? I'm not a big fan of asking the kids to memorize, but when you understand something, when you write that in your own words sometimes, it helps you remember it better. Okay? So, now this mystery is decoded. We were saying that we don't know what will be.
Wait,
Now we know.
does that mean the answer of 5 to the power of negative 2 is 0.10?
No.
Technically, because
It is 5 to the power minus 2. What it became? 5 to the power 0 minus 2. Or 5 to the power 0 by 5 to the power 2. Or 5 to the power 0 is 1 over 5 to the power 2 is 1 over 25. It becomes, if you want to convert into fractions, it becomes 0.04.
so that's the answer.
So I'm not looking for this as an answer. I was looking for this as an answer. So this becomes 1 over 5 to the power 2. Meaning when you have a negative power, you can convert that into like this. Okay? If now let me pick up one problem. One problem from the previous test. And we will not try solving it. We have only 5 minutes. But we will just try to get our head around that to relate to these concepts and see whatever concept we have learned, is that good enough or not. One of the question was 3 to the power minus 5 into 1 by 3 squared into 1 by 3 to the power minus 8. This is what was to be solved. This was one of the questions. Right? Remember, you guys?
Yeah.
And if you have to solve something like this, we just saw, if I have a number to the power negative, I will straight away say this is equal to 1 to the power 3 over 5. You missed one of the concept that we just talked about. I will explain in 1 minute, okay? Now, this is into 1 by 3 to the power 2. That is 1 by 3 into 1 by 3. Into 1 by 3 to the power minus 8. Now, this is nothing but 1 by 3 to the power 5 into 1 over 3 into 3, 9 into 1 by 3 to the power minus 8. That means 1 to the power minus 8 by 3 to the power minus 8. Yeah?
Yeah.
1 over 3 to the power minus 8 means this to the power this and this to the power this. Now look at this. This 1 to the power 1 to any power becomes 1 only, okay? So this is, in the numerator you have only 1, here you have 3 to the power 5 into 9, that is 3 to the power 2, 3 into 3. Into 3 to the power minus 8, you can make this guy go up and it will convert to a positive power 8. And then you have 3 to the power 8 and here you have 3 to the power 7. So 3 to the power 8 divided by 3 to the power 7. What does it become? 3 to the power 8 minus 7. That is 3 to the power 1. That is 3. Did I do anything new? No. I applied this concept. Just now we learned. This is simple. This one minus power you all just learned. So we are just applying that, writing that in simple mathematical way without any intelligence. I have natural intelligence, no artificial intelligence. So I just applied the natural intelligence, no AI, no ChatGPT. This is what we got. I was thinking about this new intelligence called natural intelligence. I will term it as organic intelligence. Let's keep it aside for now. But for Myra, since you missed this, I was talking about, so everybody clear, right? We will pick up few problems from this topic and we'll try solving it tomorrow. Today it's been me who's been solving the problems mostly, but tomorrow I will give you guys the opportunity to break your head with this. Because when you break your head becomes stronger. When you get your hands dirty, your hands get used to it. 5 to the power minus 2, this was the question. Right, Para? Can I say 5 to the power minus 2 as 5, 0 minus 2? 5 to the power 0 minus 2? Is that okay? Look at the second rule of exponent. Something power a minus b. Can I say this 5 to the power 0 divided by 5 to the power 2? Yeah? That is 5 to the power 0 is 1 by 5 to the power 2. So what happened? When you have a negative power, you just make it move in the opposite direction, meaning from numerator to denominator, denominator to numerator. Here in the numerator I had this. So this became 1 over 5 to the power 2. If I had 1 by 5 to the power minus 2 here, I can as well say 1 into, I'll make this guy move up. And this becomes 5 to the power 2. I can prove that, I'm just not doing it. Okay? So this, interpreting it this way, and this is how, for the sake of calculation, any time you have a negative power, you move it from numerator to denominator, denominator to numerator, and you're good. That makes sense? Everybody understood? Saurya, Advik, Arab, Sanvita, Nihan, Suhina, Dikshita, Sami, Urvi. If everybody understood, why are you wasting time with me? Go have fun. We'll talk to you guys tomorrow, same time. Alright?
Bye, sir.
Bye-bye, bye-bye.